Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. This is section 9.2, and it's about inconsistent and dependent systems. So there are systems that are inconsistent, and inconsistent systems are systems with no solution. So the solution set would be phi, which means the three equations have no intersection point between them. For dependent systems, here, the system has infinitely many solutions. The system has infinitely many solutions. So, not one or two, infinitely many solutions. Let us start with the first example. If you use the calculator, if you try to use the calculator to solve this system, you will get math error. So when the calculator says math error, it means either the system is inconsistent or dependent. So how can we find out? Use Gaussian elimination to solve the system. So let us start by the augmented matrix, writing the coefficients of x, then the coefficients of y, then the coefficients of z, and vertical bar and the constant terms. If you need more about Gaussian elimination, see section 9.1 first. All right, what to do? What is the idea? The idea is this number has to be 1. It is already 1. So I use it to make 2 and 3 0. So negative 2r1 plus r2 and negative 3r1 plus r3. Now the new matrix would be, there is no change in the first row, while the second row would be negative 2 plus 2, 0. 2 plus negative 3 is negative 1. 4 plus 6 is 10. Negative 4 plus 5 is 1. The third row would be negative 3 plus 3 is 0. 3 plus negative 4 is negative 1. 6 plus 4 is 10. Negative 6 plus 12 is 6. You notice that the second row and the third row, we have negative 110, negative 110. They are similar. But let us continue. Now this number has to be 1. So I multiply row 2 by negative 1. So I'll have row 1 as it is. And row 2 would be multiplied by negative 1. And row 3 as it is. Using Gaussian elimination, we need this number to be 0. You can use Gauss and Jordan, it's no problem. So R2, we have to use R2 plus R3. The first row without any change. Also the second row. By this operation, we are changing row 3. 1 plus negative 1 is 0. Negative 10 plus 10 is 0. 6 plus negative 1 is 5. Now we're supposed to make this number 1. But there is no way to make it 1. We cannot make it 1 using the 3 operations that we can use. And they are illustrated in 9.1. Please check that section before coming here. We have only 3 operations, row operations, either interchanging any 2 rows. We cannot interchange the third row because we will change everything. So always the third row, no interchanging. After you finished making column 1 and column 2, column 1 and 2 as you wish. Multiplying row 3 by a number, nothing will change the 0 if you multiply by a number. You cannot add a number. This is not a row operation. Using one row, multiply a row by a number and add it to row 3 to make it 1, but we cannot use this transformation here because it will change everything we made from step 1. So actually, if you have a zero here, there is no way to change it and you stop here. That's it. And you can write the equations again. So x minus y minus 2z is 2. This is the first equation. And the second equation, y minus 10z equals negative 1. And the last equation now, what do you have? Coefficient of x is 0, coefficient of y is 0, coefficient of z is 0. So actually you have 0 equals to 5. And 0 equals to 5 is not possible. So there is a contradiction here. 0 cannot be equal to 5. So what is the conclusion? The conclusion that this system has no solution because we have 0 equals to 5 and this is not possible. So whenever you use Gaussian elimination and you reach a line similar to this, zeros equals to a number, not 0. 5, 1, 2, 3, negative 1, negative 2, you immediately conclude that this system has no solutions. Let us try to do this example. Again, use Gaussian elimination. So 1, 2, 3, negative 2, negative 3, negative 4, the coefficients of y, negative 1, negative 1, negative 1, coefficients of z, negative 5, 0, 1, constant terms. This number has to be 1. So negative 2 are 1 plus r 2, negative 3 are 1 plus r 3. Then I use the 1 in row 1 to make 2 and 3 zeros. So the first row is not going to change. Now the second row, negative 2 plus 2 is 0. 4 plus negative 3 is 1. 2 plus negative 1 is 1. 10 plus 0 is 10. Please use the calculator to check these answers. You multiply negative 3 times 1 plus 3. Then negative 3 times negative 2 plus negative 4. Then negative 3 times negative 1 plus negative 1. Then negative 3 times negative 15 plus 1. Okay, and you write the answer. Now this number has to be 1. Well, it is 1. So I use it to make this 2 0. So negative 2 R2 plus R3. I'm using now R2. I finished column 1, 1, 0, 0 as we need for Gaussian elimination. And now I'm changing column 2 to the shape we need. So 0, negative 2 times 0 plus 0 will not change. Negative 2 plus 2, now this would be 0. Negative 2 plus 2, this would be 0. Negative 20 plus 16 is negative 4. Again, we have 0 equals to negative 4. This is impossible. Solution set is phi. So these are inconsistent systems. All of these systems are inconsistent. They have no solution. You will have something like this. Of course, we having a system of 3 linear equations here. So when you graph these systems, the graph of each one in 3 variables is a plane. So the graph of each equation is a plane. So we have 3 planes. So if the 3 planes are parallel like this, there will be no common intersection point. So the solution set is phi. Or like this, 2 planes are parallel. So the 3 planes have no common intersection point. So here the solution set is also phi. Here also the solution set is phi because there is an intersection between each 2 planes. They intersect at a line, but the 3 do not intersect. So no intersection point for all the 3 planes together. This means that all of these systems are inconsistent and the solution is always phi. Well, we have another case. The 3 planes, for example, like this here, like the graph here, could intersect in a line. You see, this line is the intersection line between these 3 planes. So here we will have infinitely many solutions. The solution consists of all points of this line, the line of intersection. And that's why we call the system dependent system. It has infinitely many solutions. or the three planes coincide. So it's actually one plane, one equation, repeated three times. So also here the solutions would be all the points in the plane. So infinitely many solutions. So these are two examples of dependent systems when we have infinitely many solutions. Let us see what happens now when we apply Gaussian elimination to a system with infinitely many solutions. So let us start as usual by writing the augmented matrix. And now the constant numbers, constant terms. Okay, 3 should be 1. It is not 1. So what I'm going to do here is to interchange row 1 with row 2 because I have 1 in row 2. Good. So row 3 as it is, I interchanged row 1 and row 2. And now uh, this number is 1. I use it to make 3 and 2 zeros. So negative 3 are 1 plus R2, negative 2 R1 plus R3. The first row as it is. Now negative 3 plus 3 is 0. 3 plus negative 4 is 1. 6 plus 4 is 10. Uh, negative 6 plus 7 is 1. The third row will be changed to negative 2 plus 2 is 0. 2 plus negative 3 is negative 1. 4 plus 6 is 10. Negative 4 plus 5 is 1. Now you can see that the 2 and the third rows are exactly the same. So this means when I multiply row 2 by negative 1, and then use row 2, this one, use it to make this number 0. So I add R2 with R3. I will get zeros in row 3. 1 plus minus 1, negative 10 plus 10, negative 1 plus 1, zeros. Notice here, if we write the equations, we will have x minus y minus 2z equals to 2. This is the first equation. The second equation is y minus 10z equals negative 1. And the third equation, 0 equals to 0. Well, this is a true statement. This is a true statement. It's something correct. 0 equals to 0. But now this means one equation has been removed. And I have only two equations. But how many variables? Three variables. So when the number of equations is less than the number of variables, you cannot find a unique solution. You will have infinitely many solutions immediately. So how to write the solution set? How to write the solution set? Well, solve the first equation for x. Let us start by the second equation. Go back substitution as usual. So solve the second equation for y. So it would be 10z minus 1. So this is the value of y in terms of z. And now let us use the first equation. X and minus y, write the value of y that you found from equation 2. And now you have an equation in x and z only. Solve it for x. So this is negative 10z, negative times negative is positive. And I have negative 10, negative 2, that's negative 12z. And if you take it to the other side, it will be 12z. and 2 minus 1 is 1. So I can write the solution system as follows. Solution system consists of triples, okay, triples, uh, x value, and in the form x, y, z. So the x coordinate is 12z plus 1. The y coordinate is 10z minus 1. And the z coordinate is z. So I can just write it like this. Okay, this would be the solution. And you can say that z is any real number. Z could be any real number. So if you put Z0, you will get a solution. If you put Z1, you get another solution. If you put Z -1, you get another solution, and so on. You have infinitely many solutions of uh, ordered triples for this system. Let us solve another example. As usual, the augmented matrix. The coefficients of Z. This is 1, good. So I use it to make 2 and 1 zeros. No change in row 1. You need to practice this by yourself. -2 plus 2 is 0. 4 plus -5 is -1. 2 plus 3 is 5. -10 plus 6 is -4. -1 plus 1 is 0. 2 plus -3 is -1. 1 plus 4 is 5. -5 plus 1 is -4. And as you can see also, second and the third line are the same. So when you multiply row 2 by -1 to obtain this matrix, and then when you use this one to change -1 in row 3 to 0, you will have the following matrix. Uh, 1 plus -1 is 0, -5 plus 5, 4 plus -4. So you will have x minus 2y minus z equals to 5. This is the first equation. And y minus 5z equals to 4, and 0 equals to 0. So you start by solving the second equation for y. And then you replace y in the first equation by 5z plus 4. And you solve this equation now for x. So -2 times 5, -10z, -8, z equals to 5. And this means that x is equal to -10z minus z is -11. Take it to the other side, it's 11. -8 to take it to the other side, 5 plus 8 is 13. So this system has infinitely many solutions, and the answer would be the ordered triple: x coordinate first, y coordinate second, and z coordinate, which is z. Okay, and z belongs to R. There is another way to write this solution if you want. Some people write it like this. It's okay in both cases. 11, they take z as t, they call zt parameter. So z is t, and they write here that t belongs to R. These two are the same, but in case if you see something like this, you understand that they are the same. Well, now we talk about non-square systems. We we talked about square systems, number of equations equals to number of variables, okay? But now in non-square systems, the number of variables is different than the number of equations. So here, for example, we have two equations and three variables. And notice that the number of variables is more, so immediately we will have infinitely many solutions. When the number of variables is more than the number of equations, we should have infinitely many solutions. We will work as usual, but here we have only two equations. So these are the coefficients, and the constant terms are 26 and 8. This number has to be 1, so I interchange row 1 and row 2. And now I use this one to make the 3 0. So negative 3R1 plus R2. No change in row 1. Negative 3 plus 3 is 0. Negative 6 plus 7 is 1. Negative 3 plus 6 is 3. Negative 24 plus 26 is 2. Now this number has to be 1, and it is 1. So that's it. Nothing else. Finished. That's the Gaussian elimination. I cannot continue because there is no third row. So what to do? Write the equations. X plus 2y plus z equals to 8 and y plus 3z equals to 2. And continue as usual. Solve the second equation for y. So y is negative 3z plus 2. Now put y in the first equation, which is negative 3z plus 2, and solve the first equation for x as we did before. So this is x negative 6z and plus 4 and plus z equals to 8. So x would be equal to negative 6z plus z is negative 5z. Take it to the other side. 8 minus 4 is 4. So the solution set would be, if you want, uh, I can write it. X coordinate is 5t plus 4. Y coordinate negative 3t plus 2. Z coordinate is t, and t belongs to R, could be any real number. So this is the solution. This is example 3. Similar question. 1 1 2 1 3 1 70 60. We will use this one to make this one 0, so negative R1 plus R2. Negative 2 plus 1 is negative 1. Negative 3 plus 1 is negative 2. Negative 70 plus 60 is negative 10. Now, this number should be 1, so I just multiply R2 by negative 1. If you are asking yourself, what if the second row here are zeros? Just all of it zeros. So in this case, you have one equation and three variables. So you call z, or you call zt, you call y m, and then you write x in terms of y and z. And the solution would be x equals negative 2y, negative 3z, for example, or tm plus 70, and t and m, or y and z. That's it. Okay, the solution would be like this. And in this case, we will have two parameters. But all the questions here, we always have one parameter, okay? So let us write the equations. X plus 2y plus 3z equals to 70, and the second equation y plus 2z equals to 10. As usual, solve the second equation for y. Replace y by this value in the first equation. And find the value of x in terms of z. So x minus 4z plus 20 plus 3z equals to 70. So negative 4z plus 3z is negative z. Take it to the other side, it would be z. 70 minus 20 is 50. So the solution set, let me write it like this. The x coordinate is z plus 50. The y coordinate is negative 2z plus 10. And the z coordinate is z, and z is any real number. You can always write it either like this or using the other method. Some exercises. So using Gaussian elimination on linear systems and three variables, we obtained each of the matrices shown in exercises 1 through 3. So after solving, we obtained this matrix. State whether the linear system has one solution, no solution, or infinitely many solutions. What do we have here? Zeros equal to negative 27. Is this possible? No. So here we have no solution, or the solution set is phi. What about here? Here we have z, 1 times z. This is the coefficient of z. Z equals 5. If z equals 5, you will put it in this equation and you find y, and then you find x. Then you have a unique solution. So for this system has one solution. These are kind of exercises in 9.1. Always we had one solution like this. Here you have 0 equals to 0. Okay, in this case, we have infinitely many solutions. So these are the three possibilities that will face you when you solve using Gaussian elimination. Either you reach one solution, no solution, or infinitely many solutions. Another exercise, true or false. If this is the solution of a system with dependent equations, then 541 is a solution of this system. Well, let us check. 541 means what? Means z is what? Z is 1. Okay, let me find y. If z is 1, I replace it in y. Y is 5, z minus 1. So 5 times 1 minus 1. This would be 4. Is y 4 here? Correct. So let me find x. Well, x in the system is 2z plus 3. Well, z is 1 plus 3. 2 plus 3 is 5. Is x 5? Yes. So yes, true. So this is a solution of the system. It satisfies the general solution. We call this the general solution of the system. Using Gaussian elimination to solve this system, we obtain this matrix. Okay. Translating the matrix back into equation form gives. Okay, so let us write the first equation. X minus y plus z equals 5. And the second equation, y minus z equals to negative 3. Solving equation 2 for y. Okay, this will give y equals z minus 3. Substituting this expression for y in equation 1. This is what we do, okay? We go to equation 1. We replace x, but we replace y, sorry, by z minus 3, the value we got from equation 2. And we solve this equation for x. So it would be x minus z plus 3 minus times minus plus z equals 2, 5 and z cancels with z. Oh, 5 minus 3 would be 2. This is very nice. So x would be 2 here, but y is written in terms of z. The solution of the system is, solution set would be, the value of x is 2, the value of y is z minus 3, and the value of z is just z, okay? And z belongs to R. So this would be the solution of the system. Thank you very much. I'll stop here and I will make another video about more exercises about section 9.2.